everybody. Welcome to my kitchen, which is my makeshift classroom for the next however many weeks that we're doing online learning. I just want to start by saying that I very much miss seeing all of you, and as nice as it is to be home with Derek and my cat Rigby, I do actually miss like the human interaction of actually seeing you guys every day. So let's just get right into the video. Before we took our hiatus from school, we were working in the Unit 6 Part 2 packet on logarithms. I'm going to pick up where we left off. So what you might notice is that pages 11 through 14 of the packet are actually just like review of everything we've done so far on logarithms. So you might want to start, since we've taken a little bit of a break from school, by just working on pages 11 through 14, and I already posted all the answer keys for that. What I'm going to do here is get into some new content, which is on page 15 of the packet, and we're going to talk about evaluating log expressions. So you actually do have some familiarity with how to do this already, but in particular, we're going to talk about how you can do this without a calculator. So what I'm going to be doing is example 1 from page 15 of the packet, just 4 examples. Okay. So taking a look at example 1, you are asked to simplify the following log expression. It's base e raised to the power of ln of 5. Okay, so we want to evaluate this without a calculator, remembering what we know about how logarithms and exponentials can undo each other, and remembering that the natural log is already base e. It's understood that there's a base e there. We know that these things cancel each other out, and this is simply equal to 5, right? Pretty straightforward. Taking a look at part B, we've got log of 0.01. Okay, so in order to evaluate this expression, you need to remember something about decimals and their places, right? So 1 digit after the decimal place is the tenths place, 2 digits after is the hundredths. So what I should be doing is converting this so that it's log of 1 over 100. So if we write that as a fraction, it's going to make it easier to evaluate this. Remember that anytime you see just log with no base, it's understood that that will be base 10. Okay, so what I'm working with here, I've got base 10 on the log, and inside of this 1 over 100, I could rewrite that as an expression that is base 10. If I rewrite this as log base 10 of 1 over 10 squared, and then if I take that even further, I'm going to turn that into a negative exponent. This is log base 10 of 10 to the negative 2. And right there we can see how a log and an exponential are undoing each other. Log base 10, 10 to a power, these things cancel, and I'm left with negative 2 as my final answer. Moving to part C. Part C, okay. Log base 3 of the square root of 27. Okay, so I'm seeing base 3 on the log, and I'm seeing 27 here, and I know that I can rewrite 27 as 3 to a power. And I also see that square root there. Let me just make one change to start. So 3 cubed is going to give me 27. I'm just going to make that change to start. Log base 3 of the square root of 3 cubed. Just making that one change. And now, knowing that a square root is the same thing as raising an expression to the power of 1/2, this becomes log base 3 of 3 cubed to the 1/2 power. Recall that power to a power means multiply, so this is log base 3 of 3 to the 3/2, and right there we see log base 3, 3 to a power. Those are inverses, they cancel. I'm simply left with the exponent of